Hey, Algebra 1, we've been talking about graphing, so we're going into the next unit where you're graphing more than one equation, system of equations. And we're really trying to break down really one main concept. Where do these two equations intersect each other? Where do they cross? Where is that xy point that makes both equations true? And so there's three possibilities. Either they cross like most lines in one particular spot, giving you only one solution, and that's that one point where they cross. Or they could be parallel lines, which means they have the same slope, but they start at different y-intercepts, so they'll never cross, so there's no solution. Or maybe they're the same line. Maybe you're graphing the exact same equation, and so any point that's on the first line is also on the second line. So how many points do they have in common? They have infinitely many points in common. And so really growing in this is determining whether or not do we have to rewrite the equation? Is it already in y equals mx plus b? Can we just go ahead and graph it, or does that equation need to change? So in the first one we did in class, both of these are y equals. Both of these equations are ready for graphing using that slope-intercept form. Same thing with number 2. Both of these are y equals. But what we saw on the back is where basically you start to see that the equations need to be solved for y, so I added 3x to the other side, or I added x to the other side to give me an equation that is ready for graphing. It's in that slope-intercept form. So I'm going to go to number 5. I assigned 4 homework problems today, 5, 6, 7, and 8. We did the rest of it in class together. And so let's talk about solving for y to graph something that is in standard form. So I jotted down the first equation. This one is not ready for graphing. We need to know what is y equal to when we move those values to the other side. So the first step, let's subtract x from one side to the other. 3y equals negative x minus 15. Let's write that again. 3y equals negative x minus 15. And now we need to move the 3. So let's divide 3 to the other side. And I really want to clean this up so I can tell what the slope value is. This is negative 1/3 of x. So there's like a negative 1 right there. And then I also have negative 15 divided by 3, which is negative 5. So using that y-intercept value of negative 5, if you plug in 0, negative 1/3 of 0 would be 0, and when you subtract 5, you get an output of negative 5. Well, now I really want to use that rate of change to determine where other points are, and so this is a negative line. The line should be going down and to the right, and so I'm going to go down 1, right 3, down 1, right 3, and as many times as I can. And eventually, when I graph the second one, I am looking for points, or a point, where they are equal to each other, where they cross each other. Okay? So the second line, this is a very special case, because basically this is y equals 0x minus 7. So I have negative 7 for the y-intercept, but there's a slope of 0, and basically every y value has negative 7 for it. So every one of these points, that's 0, negative 7, or 10, negative 7, or negative 10, negative 7. Basically, we have forced every point in that line to have a y value of negative 7. So we're looking for that point where they would cross. And so this would have one solution, and it would be 1, 2, 3, 4, 5, 6 for the x value, negative 1, 2, 3, 4, 5, 6, 7. And it makes sense if y is always negative 7 for one of the equations, it's more of what the x value is where that other line meets that horizontal line. So there is your one solution, 6, negative 7. So again, looking at this and knowing which equation is easy to graph because it's ready for graphing, that's very important. For example, this first one, this is in mx plus b. I can start at 5. If you plug in 0, you get 5, so 0, 5 would be a point on that line. And 1, if you plug in 1, 1 plus 5 is 6, so 1, 6 is another point. Or 2 plus 5 would be 7, or 3 plus 5 would be 8. And so that line is easier to graph than the second one because it was already solved for y equals. I didn't have to manipulate the equation like I'm going to have to do this second one. X minus y equals 2. Now, I've taught this for a long time, and I've developed a different vision for some of these problems because, for example, you're looking for points where the x and the y value, if they subtract, give you 2. So, for example, 2 minus 0 is 2. So 2, 0 is a point. But so is 3, 1. 3 minus 1 is 2. So 3, 1 is a point. Or 4, 2. 4 minus 2. Or 5 minus 3. Or 6 minus 4. See, I'm just thinking about what values are true for this equation. But that's a more deeper understanding of it because I'm really imagining what values would go in there. I may want to stick to solving for y. And so the first thing I do is subtract x to the other side. I'm seeing a lot of students miss the negative that was in front of y. Sometimes I notice students where they subtract, they don't really make it negative x on the right, but those are things that I want you to look out for. Let's divide by negative 1 to basically solve for positive y. Negative over negative makes positive, and 2 divided by negative 1 is negative 2. So this may be a more direct way of graphing it. I now have negative 2 for my y-intercept. And I'm using that slope of positive 1 to go up 1 and over 1. And now you see all those other points that I was imagining to be true. And so I want to kind of look for where these points are going to cross. And you may be thinking to yourself, well, I don't know if they're going to cross. They sure don't cross on the graph that we have. But these are parallel lines. They're both going up 1 over 1, but they start in different places, so they never cross. There is no solution point. There is no point where they're equal. Okay? So that would be the answer for number 6. I'm going to leave you number 7 because I really want to see how well you do what I'm asking you to look at and practice. So I am going to go to number 8. And that first equation, you may think, well, how do I solve for y if there is no y? Well, it's a very special problem. This is a vertical line, negative 2. I'm about to pause it. So now we got to solve for y in the other case. And once you solve for y, graph it, and you can determine where these two lines cross. Good luck, and we'll see you tomorrow.